Right now, far beyond the planets and far beyond the protective reach of the Sun, an ancient spacecraft is still speaking to Earth. Voyager 1 was never supposed to be doing this. Built in the 1970s, before modern computers, before the Internet, and before most of the people studying its data were even alive, it was designed to last only a few years. Its mission was simple: fly past Jupiter and Saturn, send back images, collect measurements, and then fade into silence. But Voyager 1 never stopped. It kept moving, crossed the edge of the solar system, entered interstellar space, and continued transmitting from a place no human-made object had ever reached before. Now, Voyager 1 is telling us something that does not fit our models. The space beyond our solar system is not quiet, smooth, or the empty black ocean we once imagined. Instead, it has a faint hum, turbulent regions, and a violent boundary wrapped around our solar system like an invisible shield. The most remarkable part is that this discovery is not just about deep space. It is about us. The same boundary Voyager crossed helps protect Earth from the intense radiation that fills the galaxy. By looking back across that frontier, Voyager 1 has revealed something scientists still cannot fully explain, something that could reshape our understanding of how life survives inside the Sun's protective bubble. Voyager 1 launched on September 5, 1977. Its original mission was straightforward: visit Jupiter and Saturn, capture photographs, gather scientific data, and complete one of the most ambitious planetary flybys ever attempted. That was supposed to be the end of the story, a brilliant mission followed by silence. Instead, Voyager 1 became something far greater. In 1979, it flew past Jupiter and returned close-up images and measurements that transformed our understanding of the giant planet. A year later, in 1980, it reached Saturn, revealing stunning new details about its rings, moons, and magnetic environment. The outer planets did more than provide scientific targets. Their immense gravity accelerated Voyager 1 through a series of gravitational slingshots, sending the spacecraft farther and faster into the darkness of deep space. By the end of the 1980s, Voyager 1 had become the most distant human-made object ever created. Yet it was still alive, still collecting data, and still transmitting its faint radio signal across an ever-expanding ocean of space. In 2012, Voyager 1 achieved another historic milestone. It crossed the heliopause, the true outer edge of the Sun's influence. This is not merely a distant region beyond the planets. It is the boundary where the solar wind finally loses its strength and the pressure of interstellar space begins to dominate. Everything inside this immense bubble belongs to the Sun: the planets, moons, asteroids, comets, Earth, and every living thing that has ever existed. Beyond the heliopause lies something entirely different: the space between the stars, filled with the ancient plasma of the Milky Way and shaped not by our Sun, but by the galaxy itself. When Voyager 1 crossed that invisible frontier, it became the first human-made object to enter interstellar space. Because it continued transmitting, humanity gained something it had never possessed before: a functioning scientific instrument operating on the far side of the solar system's boundary. What it discovered there surprised scientists. For decades, researchers had expected interstellar space to be thin, cold, and relatively smooth. It was never thought to be completely empty, but it was believed to be a quiet environment beyond the Sun's protective bubble. That expectation changed after Voyager 1 entered interstellar space. Beginning in 2017, its plasma wave instrument started detecting a persistent narrowband emission, a faint, continuous hum vibrating through the plasma between the stars. This was not a single burst, a temporary shock wave, or an isolated measurement that could be dismissed as interference. It was a signal that continued year after year as Voyager 1 traveled deeper into interstellar space. The discovery became extraordinary because that constant hum provided scientists with a new way to measure the density of interstellar plasma continuously. Before Voyager's observations, researchers could only collect scattered snapshots. Usually after powerful eruptions from the Sun sent shock waves all the way to the solar system's edge, causing the surrounding plasma to respond. Those measurements were valuable but incomplete, like trying to understand the climate of an entire planet by observing a single storm every few years. Voyager 1 changed that completely. The persistent emission became a continuous stream of information, a real-time record of the interstellar medium surrounding the spacecraft. As scientists analyzed this data, they uncovered something unexpected. Interstellar space has structure. It contains changes in density, turbulence, motion, and layers of complexity that earlier models failed to capture. The region beyond our solar system is not a calm, empty void between the stars. It is active, dynamic, and textured, behaving almost like a form of cosmic weather. Today, Voyager 1 remains the only spacecraft directly measuring that environment from within. Yet the mysterious hum continues to raise important questions. Scientists are still working to determine the exact physical process responsible for producing this persistent signal. Each new transmission from Voyager 1 brings us another piece of the puzzle, reminding us that even after nearly half a century in space, the spacecraft continues to reveal discoveries that challenge our understanding of the universe.